Good afternoon. We're ECOTONE and we'll be presenting our project. We'll start by introducing our site, clarifying the problems, and moving on to the design approach. With the increase in population, coastal land is developing at a rapid pace, with upcoming industries leading to an increase in the level of pollution. This problem is prevalent on the site we've taken up, that is Thane Creek in Maharashtra, which falls between Mumbai and Navi Mumbai. Features of the creek were mapped out, like the location of mangroves, mudflats, flamingo sanctuary, and population density. The sources and effects of high amounts of pollution were studied on site, and how the creek is becoming narrower over the years due to excess siltation. As a result, a threefold problem is created. The surface of the water has algae growth, making it difficult for the fish to survive, but increasing the flamingo population. The stagnation of water adds silt deposits on the mudflats, increasing mangroves and reducing habitats for flamingos. And finally, due to decline in fish in the area, local fishermen face a loss in livelihood. Thus, the aim of the project is to introduce floating platforms to the ecosystem, which would help filter out industrial waste from the water, assist in increasing the velocity to reduce sedimentation, and would also provide a habitat for marine organisms. This would happen while benefiting the fishermen community in the region. The design development occurred in three phases: on the urban scale, regional scale, and modular scale through the course of the project. On the urban scale, experiments were carried out to deploy the floating platforms in the most appropriate locations on site. As a starting point, high priority areas for deployment were mapped by ranking the pollution levels. And a primary zoning typology was inferred by also considering other site factors. These were areas for flamingos, fishing activities, and tourism. This formed the basis for further experimentation. Multi-objective optimizations were carried out on a grid of 120 by 120 in each zone individually, considering various factors. The optimum results were then matched in different permutations to give the required number of platforms. The results were then analyzed, and it was found that the third phenotype had the highest velocity and number of islands and thus was more suitable. For the regional level, as a starting point, we wanted to create the platform in such a way that a smooth transition would be created between land and water. For this, the principle of transitional spaces was studied based on traditional ghats and fishing villages of the region. This led to devising a program distribution between the blurred boundary of land and water.
Thus, the experimentation on the regional level aimed to optimize the form, aggregation, and contours of the floating platforms. Initially, truchet patterns were explored for their structure and iterative rules, creating voids between masses. Experimentation was carried out to obtain diverse designs to identify the best performing geometries. Then the urban grid aggregates were taken and a clustering pattern catalog was created. To replace the platforms on the urban grid, a cluster was picked from Zone B for further detailing. With respect to the chosen cluster, issues like pollutants and oversiltation were targeted. This formed the basis for further experimentations. Activities surrounding ghats and silt collection zones were detailed and spatially distributed. Thereafter, a program distribution was set and a node-based planning was carried out. For this cluster of islands, one island was considered for further detailing the spaces. To progress, we explored creating a terrain of varying heights for our selected platform to ensure stability guided by simple momentum principles. The selected form after running the experiment was then overlaid with the program distribution specifying areas. Subsequently, bounds were formed in the platform to explore the module scale and numbers to be aggregated. Narrowing down to the modular scale, the aim here was to optimize its form, material system, and its types. As a starting point, aggregated geometries and the buoyancy principle were studied, and truncated octahedron emerged as a chosen form. A material system for this form was then introduced, where loofah, which would act as a filter for pollutants, and hydraulic lime to act as a habitat for the marine life. The module forms were then aggregated into the bounding box of the island and varied in properties according to the program distribution carried out. There were 6 distinct typologies: the underwater modules and the above water modules. These typologies were further discussed. Here, the habitat module provided a home for the marine life, and filter module carried loofah to filter pollutants. For this, experimentation related to pore sizing was carried out in the module structure, and aggregation patterns were studied. Zones containing these modules were seen as areas where communities could step down to the water level to replace the loofah filters seasonally. And experiments to optimize the filter module geometry were carried out. And the material for fabrication was studied. The modules would contain an outer shell of hydraulic lime for habitat, loofah for filtration, and a hollow steel structure to make it buoyant. A part of this module was cast as a physical experiment on a scale of 1:2, using a mixture of hydraulic lime, loofah, sand, and loofah as an aggregate around stainless steel pipes.
For the next stage of the module types, sediment collection modules and green modules were taken up. The sediment collection modules were used for the trapping and removing of excess silt, and the green modules would act as homes for the above water organisms like birds. Coming to the human activity modules, the first was the semi-open module type, which would accommodate activities for the benefit of the locals. This was explored through categories like the fish market module, the community zones, and temporal seasonal stalls. To test the structural stability of these modules, each framework was taken and tested upon in order to reduce the stress and minimize the displacement. The second human activity modules were the enclosed module types, which were for more interior functions. 4 typologies were developed in this category of varying areas and functions. The typologies were initially developed to aggregate with relation to themselves and then to each other. This helped us generate a rule set to obtain a different sample outcome. Combining the semi-open spaces and closed spaces, build structures were designed based on the proximity to ghats to serve as treatment facilities for loofah. These spaces together would house activities such as loofah treatment centers, community spaces, and research centers. The recycled and treated loofah from the underwater filter was used in panels for the semi-open and the open typologies to create probiotic spaces. Experiments were carried out on different perforation types for semi-open panels. The panels of the selected typologies were placed to optimize wind direction and provide shading inside the structures. For enclosed typology, solid walls were installed only in the areas of high radiation range. And for the openings, a double skin was considered where a bamboo trellis framework would be applied. After defining the different module typologies, we looked at how one module system would interlink with another. The seasons were broadly divided into monsoon and non-monsoon periods. During the monsoon, loofah would be used as a filtrant to control high levels of pollutants. When the season is over, loofah would be cleaned, transported, and used as panels for shading in semi-open structures. During monsoon, silt modules would be heavily used to absorb excess silt from the waterway, and green modules would be used during winter times to accommodate migratory birds in this region. During monsoon, primary economic activities would shift indoors, mostly to do with the research and handicrafts, while during the non-monsoon season, fishing and aquaculture activities would support semi-open structures and inflow of tourism who buy these products.
Networks between platform systems were formed using boats, bridges, and land access. And a variation of transitional areas connecting the platforms to the land and one another in the chosen cluster were explored. The mooring aspect was investigated on the chosen cluster level. On an aggregate scale, experimentation and calculation for the anchoring system was carried out for the system. The different joineries of the platform were then defined for vertical connectivity and taking into account the wave direction in the creek. As a summation to the project, it was found that different typologies of module systems explored were actively and passively providing solutions to the site problems and coming together to form an integrated, context-sensitive system which would blend into the ecotone. Thank you.
Congratulations, well done. You've done serious work, from the very beginning up until the end, detailing every single step from macro to micro scale. It does quite I got quite excited at the very first two slides because it reminds me of, it's almost like a 3D version of the ocean cleanup, right? These guys that go and, so it does get quite interesting on how then you're starting from that thesis and you're trying to expand it into something that becomes a larger platform. And perhaps my only sort of, maybe, I don't want to say remark, but just a question perhaps is about scale. What does break the system in terms of size? When the aggregation becomes, start to lack effectiveness, let's say? Because I've seen in one of your latest sections, the system increase in depth. So I'm wondering, does it need to? What drives that depth of aggregation? And does it start to fall kind of integrity in some starting to lack integrity, let's say? So that's my first question. Then I've got another one on materiality, perhaps.
So the depth of the entire system was based upon the buoyancy calculations that we'd carried out as part of our experimentation. So each module was 2 by 2 meters, and that was taken in terms of for ease of fabrication at that particular point. And what the concept of increasing the depth was that it would be able to support more activities on top. So that was related to the zones. So for the zones where it will be mostly accessed by more locals and tourists, there will be more depth in that region to support that particular activity on top. And
And now the other question, I think, is it's quite a nice thing to make a platform, and trying to give usability. So I think program I didn't quite. I would have probably liked to see maybe some sort of facilities to treat and process the pollution, which I think is the central core of your thesis. I think it lacks that. Where does the material go when you extract it, and what does it become a byproduct, or in the filter, for example? And then the last thing is on the materiality. I think still. It sounds a little bit expensive in terms of carbon, in terms of locality, and I wonder if maybe you could have chosen maybe something alternative, especially because it's below water, let's say. But yeah, thanks a lot. It was really, really good.
Thank you.
Fair enough. Okay, I'll continue then maybe. There's a lot of work in here, and you tried to really explore all the scenarios and possibilities, and I think that's really valuable. I'm kind of struggling with the idea of the need of the platform as a platform. If I look at the project as a filtering system, as a cleaning system that maybe is invisible for a moment, I'm like, okay, no, that's really interesting. And then I look at the module and I wonder, this geometry and also like this materiality. This is like a sort of maze of a material that becomes a filter. No? So basically it's a filter and a sponge. From those principles, it's like, I don't know, that's the part that I like the most, the idea that it's not the mangrove, but it's a sort of generated filter that still remains to be unpacked a bit. So I kind of, when we see these images, I feel like it has lost a little bit that flexibility of being a bit more indeterminate, and it's a superstructure all of a sudden. So I have to be like super honest here. That's what I'm kind of struggling mostly with, and I don't know how this is solved because I understand that you need to kind of rationalize it. You have to propose a structure. So to me, it's a challenge and a question how to operate within systems that are performing under the water in a certain way, and then their buoyancy potentially can add usage. Then my question is it a shore system or is it an island system? Maybe that's the question to now just.
So we had multiple scenarios where we were studying this connected to the shoreline and then be placed at the center of the creek also in a scenario. So it was the determining factor was really in terms of the site context, where if it was connected and serving more for the habitat, the local habitat itself, as for the flamingos, then it would be connected to the shoreline. Mm-hmm. And the shoreline in our site actually is it has mud flats, so it would essentially be a part of those mud flats then. Whereas in the central zones, they would serve more as tourist related activities to bring people in and really educate them about this region. Mm-hmm. And there then it basically is suspended. So we had we have designs for like the mooring system and everything. So that's why the buoyancy was really a factor that we were considering from the very beginning. Okay. Where it would need to even be floating and then.
Right. No, that's interesting. Just what, and I pass it on. Maybe there is something that the project could have done regarding the axis of the river and the shore, like this sort of operating from the purely non-programmatic at a human level. Of course, it can be operated, like you arrive there with a ship or like a boat, and then you operate it. But this logic, maybe it's not the same. And the buoyancy requirements are different as well, which is great because then you kind of unload that performativity, you become more shore-like, and then you start expanding Earth system. So I feel like somehow you really pushed it for the integration of all, and it does everything in one artifact. And now I'm unpacking it, so just to understand it maybe, but that will be kind of my comment right now. But thank you guys. Thank you.
Hi, thank you. I think I have the same feeling as Anna. I find it difficult to understand, and most of all is the why. What is the need? I mean, why the need of your underground structure on your underwater structure? And I know it's more of a cleaning system, but it makes me think, one, in terms of scale, I think it's too much. You started with a 120 by 120, and then you blow that up into your regional scale. But your 120 to 120 is a Barcelona block, right? So why do you need such scale? I think that was my first question. And the second question is, you talk about the species and the habitats. Is this really needed? I think I'm kind of just post-rationalizing because I find it difficult to understand the need. And then it made me think, I don't argue your system and the way that you analyze and experimented. I think that it's all really nicely done. I do agree that steel may not be the most friendly one in terms of carbon footprint. But probably this system, as a cleaning system, can be, I relate it back to real world problems. And maybe this can be in this context, or maybe in another part of the world where you have the huge amounts of waste happening in the ocean and happening in other parts of the world. Can this be implemented in different ways? So it's more of a functional system rather than an aesthetic system of platform. So unless you put a function to it in a program and a usability, that you can have research labs or marina investigation, whatever, I don't know, whatever is fitted to the place and context. But otherwise, I was struggling really to understand, okay, you know, and maybe it was a little bit too quick at the beginning to understand the whole connection to the existing context. But in the end of the day, I look at this and I understand the individual models, but I don't see the reason of why such a big structure to have that in terms of scale, and why is it really needed here? Maybe it's more tactical on what this site represents and you don't need that much. So I think that's my struggle a little with your proposal. But otherwise, they're beautiful graphics and a beautiful representation of your proposal. But I think from a methodology perspective, maybe it's an application to think that it could be applied to other things that can be used for, I don't know, recycling, and not just for the fish, but for recycling, for cleaning the waters, cleaning the ocean, cleaning other systems, right? And that has a huge impact. So I think that would be my reactions. But thank you.
Thank you.
So yeah, man, last. Yeah, similar comments really. I kind of like the fact that you've been so consistent with the module, right? You really stuck to it and might make it work everywhere, which is kind of a good approach, but I'm not sure if it really helps you, right? To be so consistent with it and try to do everything with the same module. I'm also kind of questioning why that module, right? Because I don't think it is that useful for all the kind of functions that you have shown. So that's kind of one comment. A comment that I have for kind of like that I haven't said for other groups, but kind of counts here, maybe for some of the other groups as well, that I'm sometimes missing that one shot, that one view, that one render that would be able to explain most of your project, right? You try to do it here, but I'm kind of missing. I think the first group did it quite nicely with a few views, but that one view, that if you would only able to show one image of your project, what is that? It's a really crucial thing, I think. You know, I'm always, for the projects that we work on, we're always kind of very careful to have that one view, that one image, because most often only one image survives of a project, right? And I'm missing that, right? Because I want to see how people would live there, how that fishing community would live there, how, you know, and not that in diagrams, but it kind of, it could be photorealistic rendering, it could be any way, right? But to get that feeling of how it would be, what the scale is, how it is to live in these places, and it's for the other groups as well. You know, it's important to get that, especially when you kind of, in a presentation like this, you always end up with one image, right? And that's the one we all talk about and look at the whole for most of the time. So it's really crucial in any presentation you do what that last image is. And yeah, it'd be good to do that each time. Yeah, but congratulations.
Thank you.